Pete, or are we ready, Pete?
We are ready.
Okay. Okay, welcome to our weather discussion for this week. We have some very exciting news on the long distance horizon. It appears that we could have a pretty big and the only big snow, perhaps of this whole winter, is about a week away, maybe. So I'll let Michael talk more about that. And it's funny, when it's that far away, it's probably unlikely that anything in the sort of initial condition roundup part of the discussion will have too much bearing on that potential either. And so that's a real blessing, actually, something to reflect upon, because in our field, when I started out, you wouldn't possibly have that situation where you'd say, well, we got something so interesting coming up in a week, but there's no observations right now that say anything about it. We were hoping to get the right forecast 2 days downstream. So it's really a big change over a short period of time. Can we get a little more of Canada here? See some of those truckers? Oh, I guess.
Maybe the mesoscale image is down on them. You like the black and white, right?
Yeah, that's neat. Great, that's great. So here's our satellite picture over a large part of the Western Hemisphere. Here's parts of South America. Here's Canada and the United States, and then Central America and Mexico. So we've got a really nice picture of what's going on around that broad region. Pretty nice day along the east coast of the United States. They've had their share of winter weather over the last couple of weeks. It looks like a respite for now. This cyclone, we'll see this again in the infrared. It looks a little bit more obviously organized in the infrared, although even in the visible, it's pretty well organized. There's a cold front cutting across Indiana, Illinois, parts of Missouri. We'll see on the radar that there's a pretty decent amount of rain associated with that boundary. Then the circulation center was a couple of hours ago anyway over the eastern part of the upper peninsula of Michigan. And I think maybe the leading characteristic of this storm that's in our vicinity is that there's really gangbusters cold advection on the way. So we started out really warm today, and it's not going to stay that way. It's going to get quite cold. It's going to be a pretty brutal weekend in terms of temperatures. And then some slight moderation in the early part of next week, and then something interesting at the end of next week. So that's kind of the broad picture that seems to present itself this morning. Across the south, actually across the entire western half of the country, pretty much cloud-free, except with the exception of some upslope, perhaps clouds, in this northwesterly flow from Montana down to northern Kansas. But boy, the coast is pretty clear. Much of the southern central plains is really clear. Almost all of Mexico is clear, and then the southeast United States enjoying a really nice day. So we're really the only part of the country that's experiencing organized inclement weather, I think, and that's the way it is. Here's some snow. Look at the snow on Lake Winnipeg. Really nice, isn't it? Yeah, you can see the snow in North Dakota. As the clouds move away, none of this white moves away, so that's pretty nice. And then Lake Winnipeg is covered with snow, so clearly covered with ice as well. And then a lot of the lakes in Ontario show up as well on a day like today. So kind of a nice picture.
That snow shows up really well on the day cloud phase.
Oh, is that right?
It shows up at bright green, yeah.
Okay, let's take a look at the accompanying radar, if we could, Pete, before we go to the west. And so here you can see the precipitation associated with the cold frontal portion of that cyclone. And we don't see any of the reflectivity that's likely occurring in the clouds over Canada. There's just no radar that we get this mosaic from there. And so pretty decent rainfalls. We'll take a look at the surface map in a minute. So I think some of these places have had moderate rain during the morning. I'm not sure that's continuing to be the case now, only because I haven't looked at the odds in the last couple of hours. This little strip of precipitation, we'll have to check what the precipitation type is. I believe it's now snow, and this is right along the leading edge of some really brutally cold air. I think we'll see that when we take a look at the surface observations in just a second. And then here is, as you can see, little waves almost of upslope, perhaps echo in Wyoming, Colorado, parts of Montana. In addition, some features that are in the northwesterly flow all by themselves, probably not upslope. There's a combination in some of these western high plains states today. But generally, there's cold air sagging through the central part of the country, beginning its sag. And so the western boundary of that cold air dome is going to start to go upslope, and that impacts the weather in those locations, for sure. Okay, so, but as you can see, around the country, though, a pretty nice day for mid-February. Not too bad. Okay, can we go to the 500 millibar map first? Oh, you know what? Let's take a look at the surface off first. I wanted to take a look at some of those places around the country. Sorry, Pete.
That's all right.
Okay, then we'll zoom in. So let's start here where we've got light rain in far eastern Michigan, light rain in northwestern Ohio near Akron, and then the precipitation that we saw on the radar over southern Minnesota and spreading into Wisconsin. It must just be a bald spot in the observations on this map. But it's snowing at La Crosse and it's snowing, is that Albert Lea or someplace like that? South of Minneapolis. So some of you Minnesotans know, what is that station? Rochester. Benji, you know the whole map of not only Minnesota, but just about everywhere, doesn't he? Have you noticed that about him? He knows everything about maps. So that's Rochester. Okay, the Mayo Clinic. Okay, and then snow in northern Iowa. What's this one, Benji? Is that Storm Lake?
No, Storm Lake, Mason City.
Mason City, okay.
So John, have we changed our standards now for brutally cold? Because I mean, if you look it up in Minnesota, it's 2 or 0.
Ooh, hey, it's February 11th. That's pretty cold for February 11th. Okay, maybe we have. I hadn't even noticed that. Maybe I have changed my standards. But that's, look at this, -9, -6, -4 at noontime. That's pretty cold.
That's a regular cold out.
Oh,
I think brutally cold is -25, like further north of
okay.
there.
Well, but that's a valid argument. Maybe I overstated it. But we're starting at 40. We were over 40 before even today, but now the wind's gone northerly. So we were a little higher than 40 maybe in the last hour or two. But anyway, that precipitation to our north and west is light snow. We'll probably see that later on in the day. Did you say something?
I was gonna say that you, Greg, and I, and Pete are all over 40.
That's true. That's true. And we can be brutally cold.
Right.
So keep that in mind. So, look at that, -9 at Fargo.
Look at the winds.
Benji, is that Fargo?
Rain for it.
Benji, you want to come up here and tell me? And
Look at
Grand
the
Forks,
winds, too.
yeah, 35 knot northerly wind, blowing snow, -9.
Obscured ceiling, right with the X there, obscured ceiling, so they can't even tell where the ceiling is.
That's brutal.
There's
Okay, so
blizzard warnings right there right now.
Is that right?
So they're yes, but blizzard just from the snow that just faster.
Yeah, and that was the snow we saw on the satellite too, yeah. Right.
The University of North Dakota Grand Forks is actually closed today due to the temperature and wind chills.
Really?
Yeah.
That's brutally cold, I'd say.
They're working us there.
That's pretty cold, yeah. But look at, it's locally cold here, and then 13 degrees in the far western part of the state. You'll see at 850, the cold pool nose is like right here. So it's really robust, and it's headed straight towards us. So we're going to get colder, I guess maybe brutally cold a little bit. What was the other place we wanted to look at particularly? I'm not sure. There was another region of precipitation. Oh, I wanted to see how heavy it was raining along the frontal band of precipitation. And it looks like light rain in most places. All the way through the central part of Indiana is light rain, temperatures nearly at 40. Same thing in eastern Illinois. 44, oh, look at that. What a miserable day in St. Louis. 44 over 44 with Monsanto coming out of smokestacks. That's miserable. But look at this. Further to the east, 52 over 34 in light rain. So much warmer. And then you get into the much warmer area ahead of the front when you get between these two stations. This is probably right on it, and then St. Louis is just behind it, by my estimation.
Could we go to the Wisconsin map, the higher resolution map, see if we can see where the front is at this point?
Oh, yeah.
The models are timing the passage around 21Z or so.
It's literally between us and Dogville right now.
That's what's actually passing.
Look at the map.
Yeah, so 41 over 30
There it is.
with westerly,
It's north of the Delta.
westerly and northwesterly winds. Yeah, is this rain? It is rain. 34 over 27. Heavy rain. And then all of the stuff to the west is snow. You can see a little bit more snow than we saw before at these stations in the middle part of the state, and then these coming off the lake. It's pretty snowy. So, yeah. So, it's going to get colder. Maybe it'll take a while, but it'll be colder by Saturday. Okay, can we go now to the 500 millibar map? Thanks. Okay, so here's our analysis from this morning, and it's kind of almost typical for this time of year. Pretty decent Hudson Bay low. This is minus 47 degrees or minus 46.9 right at that spot. This is the minus 45 isotherm. That's pretty cold. It doesn't usually get much colder than that at 500 millibars. And for February 11th, that's pretty darn good. Big ridge over the west coast, and then variconicity in the northwesterly flow. Remember, we saw a couple of little features that seemed too far away by my eye from the increasing of the slope of the terrain to be associated with upslope in the radar. So maybe a couple of those are related to these a couple of spots in the northwesterly flow where the thermal field is a little out of phase with the geopotential height field and gives rise to cold and warm advection couplets. And that might be enough to make a little bit of the rising air in the right spots here and there to get something going. But we have a fairly decent baroclinic zone across parts of Nebraska with minus 30 isotherm right here, and that's kind of the leading edge of that cold air. And then this is minus 20, so about 10 degrees across Michael's home state of Nebraska. And some strong shear, we have 70 knots there, and it's down in the 40-ish range on the southern end of it, so, and cold advection. So geostrophic cold advection and cyclonic shear, likely a little bit of depression of the tropopause occurring there over southeast Nebraska and northeastern Kansas. And yet, I don't think it has much impact on the weather for us because that's a broad trough into which maybe a local minimum in the tropopause height will be injected. So if anything comes of that, maybe it's to our south over the next day or two.
Just north of Minneapolis in the geopotential height field in this analysis, there's a little bit of a trough. I mean, there's a really small kink in the
Right there.
isotope break. So I'm wondering, it's small scale, but that could be enough to also be associated with the,
That snow we're talking
That's
about,
not
could be, yeah, this is, what is that, maybe 30 degrees of direction change? So one should have at least that much change in the curvature of the isodips. So yeah, we're immediately at 12Z. Central part of the state is down shear of a little upper wave, so for sure there's something in there. And that does have, and that's a fairly consistent, persistent pocket of radar that seems to be downstream of that, so that's interesting. And the stability is probably low because it's very cold. So you've got all those right things to kick off a little shower. But a broad trough across all of North America. It goes from the border of the Yukon with Alaska all the way to Newfoundland. That's the nature of this big trough axis. And chilly air over the Great Lakes states and to the north, particularly chilly as you go to the north and west. So let's go down to 850 before we go to the jet. I want to just see what the temperature structure looks like there. So yeah, look at that. That's diamond. So this is a really shallow, well, not synoptically deep, but a pretty intense baroclinic zone. This is not because the orography's, high or anything like this. This is just, it's darn cold. So it's minus 18 in central North Dakota. And then on the warm edge, you're at minus 1 at Rapid City. So that's, nearly 20 degrees C across this baroclinic zone, even though 15 or 10 or so are analyzed there. That's sharper than that. And Cyclone Center is right over central Lake Superior, so we're in the prime cold advection zone for later in the day. So we should tap some of this minus 18-ish, minus 15-ish air at 8:50. And we started the day, Green Bay is minus 4, and we're like 0, or maybe minus 1. So that's a big temperature drop that's on the way. So we'll see how that's going to play out. Surprising, but not surprisingly, there's not any precipitation along the leading edge of this cold advection because this is a local maximum in cold advection. And you can show, when you think about it in terms of the Q vector, that's going to produce substantial divergence in the Q vector along the isotrope. And that is a forcing for subsidence. And if it's not, replaced by some other forcing for ascent, you're not going to get much of any sort of cloud or precipitation signal with that feature. And it's almost like it's a secondary shallow Arctic front. Here's the primary cold frontal structure anyway, but it doesn't really show up very much in the thermal field. Okay, so that's the feature of interest right now in our environment. And really cold air to our west and to our northwest, so that's exciting. Can we go to 300 millibar feet? And so we'll have to go to another level after this. But it seems to me, at first glance, so here we have a nice polar jet meandering through the high and mid latitudes. And it's very strong on the western side of that cold dome that's beginning to emerge at low levels especially. And then a subtropical jet, most likely across the Gulf of Mexico and northern Mexico itself. And then perhaps something of a combination of the two off the east coast of the United States and Canada. So let's go to 200 millibars, and here's a prediction. This will look weaker, so we got 154, 130 knots, and this feature here will look stronger, especially over the Gulf of Mexico.
Can I mention one thing before you go on? I think with that strong jet rounding the top up there, we should have,
This one here?
yeah, I would think that's going to create maybe strong sinking motion on the axis of the jet, and then more rising motion to the east of that.
So rising here and sinking right in.
Yeah, and I think that's lifting the cold air off the ground and creating this cold bubble at 850.
Okay.
You see what I mean?
This is the long distance from 850. And I,
Right, but
yeah.
there's a deep circulation, and I think the overall rising motion at low levels is creating really cold air at 850, and that's what's surging south.
Well, that could be true. I don't like 300 millibars for this reason. It's hard to make any sense of what type of circulation might be associated with the combination of the wind speed and the thermal field, because
Right.
right at that boundary, you're at the tropopause, pretty much. The temperature is really weird. If you did 400 millibars, I almost argue with 400 millibars.
Yeah, I see your point.
You know, then it's easier to see what you're saying.
But there should be, you see cold air advection at lower levels.
Yeah.
Right, but at the upper levels, I would think that you're still gonna get this, you tend to get a pattern that's gonna follow the tropopause, right?
Yeah.
Where you're gonna have,
I would think.
you're gonna have sinking motion on the axis of the jet and then relative rising motion on either side.
Yeah, I would think that's right.
You can make that happen if you want to. Nothing that says that.
Oh, that'd be great.
I
I'd
mean,
love
not
that.
right now, but
Yeah, but I'd love that. I would love having a 400 milliwatt map. We'd be probably the only place on earth that does it, but you can, I think you can see some more of the structure near the tropopause, but below it, so you can see some of the upper frontogenesis.
UW-AOS is the
Right.
birthplace of satellite meteorology and
400 milliwatt, yeah. So let's see if we go to 200, what does it look like? Yeah, look at this. I don't know if the wind speeds are greater, but this is more robust looking structure. Certainly is greater wind speeds down over the Gulf of Mexico. So that features a subtropical jet. And this is much weaker, a little bit higher, and so that's clearly a polar jet. And the feature here, it'd be fun to take a cross section through there. Maybe we can do that on tropical or something and just see what it looks like. But that's probably a mix, although I don't think they're vertically superposed. I think one is here, polar jet maybe there, and subtropical jet a little further to the east on that. But that's a nice way to see what we're surmising about the nature of these jet streams. Because it does matter which one's which in some ways for various metrics that you might want to measure. Okay, let's, can we go to the West Coast satellite now, Pete? If there's no comments or questions about that? Okay. So kind of an interesting satellite movie over the West Coast. Well, let me get you situated first. Here's Hawaii, our 50th state. Here's a very nice looking cyclone at, look at where the latitude is. This is almost, I think it's in low mid latitudes, but it's sitting out there in the Central Pacific Basin with its feet in the tropics. Clearly Hawaii, Honolulu is at 23.5 or 23.8 degrees. So this is clearly coming, this stream of cloudiness and the moisture associated with it undoubtedly from the tropics. So the same with this feature that's kind of arching poleward towards the west, the eastern coast of Alaska. There's not really nicely organized cyclones per se, at least by this angle. So it's oblique by the time you get to the Central Pacific, so it might be hard to tell whether or not that's got a better looking organization. It's very convective looking, even in the cloud edge to the west. So this might be a region of something about to happen. Clearly very cold over the Bering Sea and south of it, open cellular convection all over the place there. Not true off the west coast, which is another place where you often see that and with a better angle. But not today. This is much warmer than necessary to produce this shallow but widespread convective activity. So it's an interesting and somewhat boring feature across the picture in the Pacific satellite picture, except for the strong northerly flow that we saw evidenced in the 300 millibar jet and the 500 millibar flow, the big bridge off the west coast. You see strong northerly flow headed into the central part of the country, and undoubtedly, as Greg was pointing out, various circulations along that northwesterly flow are massaging the tropopause and changing the thermal structure through deep layers of the atmosphere.
So a couple of questions that will lead into some things on the show at the beginning. One, just from your perspective, looking at the early part of this semester, is this a more active set of cloud pattern than the Central Pacific and further to the west? That you've seen earlier?
Yeah, I would say it's more active, but not as, not conforming to what one expects, I would say, at this time of year. I would expect more of a parade of obvious cyclonic type structures of varying sizes.
Right.
With cold air coming off the continent over the Pacific Northwest, that's been a little bit less frequent in the 3 weeks that I've been back than usually in late January, early February. But the nature of cyclones like this that are kind of weirdly structured in this thing, those aren't the most common pictures I recall from looking at Pacific satellite views.
Right, because, I mean, today it's pretty evident, looking at the IR image, and also you saw the 500 millibars, that there's a nice ridge that's planted right off along the west coast,
Yeah.
westerly flow, so you can see the surface heating up really nicely in the IR. It's
Yeah,
really
look at
dark.
Beautiful.
And that has implications for, I guess, the Super Bowl in terms of the warmth that they might
Oh,
experience
right,
over
yeah.
the coming weekend. But this ridge that's been there for a while is at least forecast in the short range to begin to break down. And I was just curious if you thought there was anything in this pattern that might be suggestive of that.
No, I don't, I guess I don't know enough to say. I don't have any instinct about it, let's put it that way. So, yeah, I better withhold on it.
Isn't that cyclone there over the mid-Pacific, isn't that kind of odd, the way it's so close to the surge from the south?
Yeah, I think it's really weird. I think it's just a weird looking satellite.
I'm trying to reconcile what that cyclone has to do with, and I'm not
Yeah, I don't
sure.
know. And Fridays this semester are tricky for me. I can't really get time to look at those features and kind of give them an investigation that I'd like to for the discussion. So I don't have anything more I can say about it, except you're right. It's very odd that that's the nature of this picture.
It must be low level, not go up very high. But the clouds are pretty bright spots.
Yeah, yeah. And in fact, you can see obviously lower level clouds and then higher ones. So it looks like there's multi-levels to that whole structure. And it's all cyclonic. So I don't know what else to say about it.
But if you look at the shear between that surge and then that, it's got to be a very strong anticyclonic vortex almost up there. You see what I mean?
Yeah, I do. Yeah. Because you've got northerly flow here and then, or southerly flow and northerly flow.
Yeah, right next to each other.
Yeah.
That's really,
Can we take a look at the 500 Millibar map again? I don't remember. Let's get a good bearing on where we are. We're sort of right off the coast of like a San Francisco latitude and Kodiak
I'm
Island
not
longitude.
sure if that map goes far enough west.
I can't remember either. It might. Super Pete usually answers all our prayers, but here's Kodiak. Right about there. So that's got to go down that way, and then San Francisco's out there. It's not quite. So this is below. This is the upper signature of the feature that we see the cyclonic spinning, and we're missing what's upstream.
so maybe it's just an orphaned cyclone from the previous.
Yeah, it might be. It might be. It might be. Maybe there's some we can see here. So here's the anticyclone. Here's the cyclone.
Hawaii's out here. This is 500 millibar
Yeah.
heights of vorticity.
And yeah, so there's no obvious ridge. It's just this cyclone, and this is the feature that we saw spinning around. But why is there? The flow is kind of coming up. You can see that it's connected to that, the part that goes northward. But how does it really get itself to that latitude? It's a little bit hard to understand from this picture. So maybe 700 at this time.
I guess this purple here would probably be the anticyclonic vorticity that you're talking about. That's kind of
Yeah, and I was thinking you might see some sort of a ridge structure.
Where did you want to go? 700
at the same time. Sometimes if we're lower down and we're looking at a lower latitude, you might be able to see. There is the
It's vertical
anticyclone.
motion and height.
So there's an anticyclone. And then here's the cyclone of interest. So this thing is spinning around, and then there's flow going straight north this way. I don't really think I get it.
It is kind of weird.
Hard to figure it out. It might be a bit of an optical illusion. This latitude line might go here, and so this
Yeah,
flow
it
is
does.
really connected that way.
You can see the border of Alaska would be a longitude.
Yeah.
That's pretty good.
Okay, I think that's all I have for the overview.
Thank you. Yeah. Good, so where to start? On the first,
You want the other,
you're up there. So one thing we'll do is just take a quick trip to the tropics. John loves that part of the world. Here's New Zealand. Here's Eastern Australia. And there's Tropical Cyclone that's out in the Southern Pacific. What I thought was really particularly interesting about this, if we can start the loop on this, where the loop is adding it, that's good. Okay, so with this nice cyclonic circulation and this broad anticyclonic outflow, I mean, something that Greg and I have been looking at, are the outflow from tropical cyclones, and just looking at the impact that they can have on the larger scale circulation. This is, I think, really a nice example of it. You can see this relatively sharp cloud edge on the southwestern side of the cyclone, and we'll see when we look at a set of maps, there's antibarrical density here, so you get a really strong jet. But this is forming the edge of a jet. But also from that outflow, you have this large positive anticyclonic potential vorticity just northeast of New Zealand that we'll see in the maps as well. So if we go to the tropical tidbits,
Is this the prime season for them right now, Michael, or is this kind of the tail end?
to be honest, I am not certain.
I
Greg
think
shaking
it's
his head.
spring season.
Oh, it is, okay, because I was wondering, because this, maybe this looks a little more like our October, November conversion storms as they head to the mid-latitudes, but maybe not.
I think it gets even stronger in March.
Oh, okay.
So March is kind of like August.
August.
Here, August, okay. So here's where that tropical cyclone, and I can't recall the name of it, but look that up. Here's the tropical cyclone, and here's this just fantastic jet with, again, this broad anticyclonic circulation, nice positive potential vorticity anomaly in the upper troposphere, anticyclonic potential vorticity anomaly, but positive in that region. And we can actually, so this is at 200 hectopascals streamlined, and you can see just the location of the cyclone. But you can see in the satellite image that broad cloud head that was emerging from the tropical cyclone. Again, there has to be significant barochronicity here to support this strong jet structure. We could look at a couple other variables associated with this. Over some upper dynamics. Call it that. We look at the potential vorticity. Unfortunately, on this page, they multiply everything by -1. So this would really, typically be negative. Sorry, it would be positive. It would be, it's positive, so that's right. It's low, but positive. And then this would be highly negative if it's cyclonic over that form world. But you can see also extending from this cyclone, this is the relative vorticity, you can see the strip of vorticity in the lower troposphere that sort of extends across New Zealand from it, which is kind of an odd structure.
And if you put a cross-section through that, through the jet, it would look like a deep cold front.
Let's take a look. Like this?
Yeah,
Right, what's the method control?
I think it's control, click in that. Advance.
exactly, even the length of the
Now we can change the variables once you get to it.
look at that.
Good call. So here's our strong jet, and you can see the structure that extends. Really interesting, this PV structure that extends all the way down to the surface. And there is some barochronicity associated with it. I wouldn't have immediately said, oh, it's a cold front. What clued you into that?
Well, I guess because of the parallelism of the low-level vortex structure and then the jet structures in the same place, I just thought this is probably gonna look like a cold front. And it actually looks like the amalgamation of two, sort of like an upper front.
Uh-huh.
Then between 600 and 400 millibars, the barochronicity weakens, gets sharper again near the ground.
Right.
So,
It's really
it
strong.
just
You
happens
can see
to look
that,
like that.
right, that barochronicity, you can really see it here with the isotropes.
And being, tropical tidbits, instead of extratropical, they draw every 5 degrees K, so you don't want to, say that it's not a strong barochronicity. You'd do every 3 if you were extratropical tidbits.
Yeah. So, really nice, the cyclone, yes.
Just to comment on the countries already in a sort of emergency, maybe like 5 days before the cyclone actually gets it. Like cold front's already dumping water on the
Right.
west coast.
Also, you say there's already flooding that's occurring.
Yeah, Eden's Ridge is washed out and the whole west coast is said, wow, pretty much.
Well, and with this broad anticyclone, I mean, that's gonna have a inertial stability that's relatively weak, so I guess convection that develops in this region is gonna just be a little.
Look at how
Develop
I mean,
robustly.
to the extent that you can really believe those small-scale structures, the tropopause at 100 millibars or between 200 and 100 millibars is just like a Swiss cheese above all the way the convection's going on. That's really interesting. It's been eroded.
Yeah, let's actually look at the precipitation and moisture we get out of those things. Thanks for the comment. Let's see how this is, yeah, we can look at,
Whoa. Look at that.
and that's probably no surprise why you see this, that vorticity strip, which would also be a lower
Yeah.
troposphere condensed vorticity strip, with all this diabatic heating that's occurring along this, and there's barochronicity here, which frontal link. You're gonna get a potential vorticity generation in a strip. And so that's really,
It's a predecessor rain event.
Yeah.
That's a
it looks
creek,
like-
yeah.
Yeah.
there's like with the barochronicity to the north of the tropical cyclone. South of it, it's a polar to the tropical cyclone, you get these, as Greg just said, predecessor rainfall events. We typically see them in the northern hemisphere, but this is a nice southern hemisphere
Yeah.
example, right? Okay, so we'll get out of the tropics. Been there, done that, we've seen it. And what I'd first like to do I mentioned that ridge that was off the west coast of the United States. I have some GIF images that are already loaded behind this map. I'll just sort of step through a couple of them. First of all, this is the average 500 millibar geopotential height, the composite mean, based on the NCAR-NCEP reanalysis. That's there. This is from the 15th of this month, of last month, through the 8th of this month. And it kind of should get you a sense of the broad structure over North America that we've experienced over since basically the beginning of the term, but just before. With this broad ridge that's just been along the west coast, or just west of it, kind of a split flow just east of Hawaii, with a trough to the south, ridge to the north, broad anticyclone. This trough over us has been responsible or associated with some of the relatively cold weather that we've experienced over the last several weeks. And we're going to see when we look at the forecast that this is going to begin to break down. And sort of regime changes perhaps in the offing. I'm not going to really speak to why that's occurring, but it's just curious that we're reaching the sort of the end of this pattern. And we can sort of come back later on and look at this to see if it actually verifies. What are some of the consequences of this and how anomalous is this? We go to the next figure that's over here. This is the correct one. This shows, oh, I'm sorry, there's another one behind it. Or behind this. Right here, thanks. So this is in meters, 500 millibar geopotential height meters. These are the anomalies. Again, you can see this really robust ridge that's been parked off the west coast of North America, and then a portion of it extending all the way up westward and northward over parts of Siberia, deep trough over the north central Canada, and then a broad ridge over the Atlantic as well. So again, that sort of sets the tone for what that 500 millibar height will look like. And then finally, if you go to the image behind this, this is the 850 millibar the temperature anomalies, and then a lot of warmth, 7 degrees warmth over parts of Siberia. There's a cold air event that's been over Canada with some plunges over us. I think some of this is recently the cold air that was over Texas that they experienced last week. But that's what the last almost month, last 3 weeks or so, that's what the pattern's been. And again, the notion and the forecast is that this is about to get disrupted.
Question real quick. So I've kind of been taught and under the understanding that the global models are actually not that good at forecasting the breakdown of anomalous walking patterns.
Right.
So given the lead time of this forecast, how much credibility would you actually put in this kind of change given how persistent it's been?
No, that's an excellent point. When you've been in a long pattern, you want to persist your pattern, right? You go with persistence. But I think there's been a lot of signals from different models that seem to suggest that a pattern changes in the offing, and even the short range, it's already beginning to show up.
And do we have any information on what's catalyzing that change?
Not certain. That part I haven't looked at. But you're going to see evidence in the short-term forecast, something we haven't seen in quite a while, about to happen. But again, at least in the models, and this is within the next week, the next 3 or 4 days, in fact, off the west coast, they haven't seen. Let's go to pivotal, please. And the first thing I want to do is just go to observations. And another aspect of this pattern is the drought monitor. So this is the U.S. Drought Monitor, the Drought Mitigation Center, back in my home state of Illinois, Lincoln. Illinois, what is it? Nebraska? Oh my gosh, I have real affection for your home state. Okay, in all seriousness, I mean, look, we have severe and extreme drought conditions over much of the central and western United States. Even here in Wisconsin, we've been in a deficit of snowfall. That's also good, just equivalent. It's been pretty dry in this pattern. We had a really wet period, I guess in late November, early December over the western part of the United States when they had those big snows. That sort of was hopeful that might be the start of a wet season for them, but it hasn't materialized. As we'll see in the forecast, again, that's about to change. Let's go to the models.
Can I make a quick note about the stupid?
Yeah, please.
So something else that's interesting is the drought monitor map is also often a proxy for looking at where elevated mixed layer source regions are and how far east that translates. So from a seasonal perspective of severe weather, you can already pretty much tell that most of the severe weather activity will be east of the I-35 corridor in Oklahoma, and you might even see more southeastern U.S. type severe weather events as the elevated mixed layer kind of gets pushed over further east, originating over the higher terrain in the Texas Panhandle.
That's actually an interesting point. So normally you think of these elevated mixed layers coming off the Mexican plateau and then being affected. But the fact that it's so dry here, you're going to get deep mixing, and that'll allow this to extend even further to the east and northeast.
So from a seasonal perspective and kind of being this neutral La Nina, El Nino kind of flip-floppy pattern, it's kind of looking like March, April, May will be quite active like Arkansas.
That's really interesting. I hadn't thought about that.
Yeah, if I can follow up, does it struggle, does the elevated nature of the mixed layer struggle to get elevated if it starts out on the plains?
Not if there's lift, so like cyclones, and coming off the lead of the Rockies, you can bring that elevated mixed layer up without having to originate on higher terrain just through mixing. So if you get deep, dry boundary layers and lift, you can kind of transport that. Most of the East Coast and Southeast major outbreaks happen when you're able to transport an elevated mixed layer that's relatively untouched out further east. And so kind of the thought process behind that too is these deeper boundary layers with more mixing and heavier drought conditions is that you often don't get as much convection just because your capping inversion is much stronger. And so it's easier to transport those mixed layers without disturbing them as well once you get them to elevation. You don't even need them to be that high.
So is there effectively, as these mixed layers storm over the Mediterranean, Mexico, and then move northeastward, the fact that, we say it's dry here, so you have a potentially deeper boundary layer here, is there a coupling or is there a mechanism that helps foster that coupling between ones that develop over the southern plains or the ones that maybe just elevated above them?
Yeah, I'm not sure.
But it's really interesting that
Yeah.
the impact of a seasonal deficit in precipitation can have an impact on.
And there's still a lot of ongoing research into this area, so it's still fairly qualitative, but it's a fairly common pattern that you'll hear severe storms forecasters talk about is looking at the drought monitor at this time of year to kind of get a gauge for where that activity is gonna be. So like years like 2011 and 2013 were substantial drought in the Central Plains, and those were years that had massive outbreaks in the Southeast and the East Coast. So it's just there's some relation there.
Okay, well, thank you. Let's go to models, and then we're going to look at a slightly different model than we typically do. We look at the PERB, high resolution rapid refresh run. I'm not sure how far this is far enough out. Let's change our view or perspective to the regional, please. West. And let's put wind temperature points on this. So this is the analysis as of 17th, so 11 a.m. And you can see where that cold air is and the nice wind shift associated with it. We saw evidence of that certainly in the analyses that he produces at the edge of that cold air as it advances. We'll just step forward in this to get some estimate of the timing, and we can do some comparisons between the models. So these are every hour. These are done, these analyses and the short range forecasts are done every hour or so. So it looks like we get to the Dane County, upward click, here we go, shifting to northwest around 21, 22Z is when that cold air comes in. And if we look further, putting the cursor over here, we can just hovering it over. That is to look at just about freezing at that point. And we go back into the deeper cold air, the northwest already down on below 0 Fahrenheit. This is cold air begins to arrive.
Where's the brutal contour?
Yeah, I think it's in the purple. I think it's in the purple. That's arguably brutally cold.
If you want to see brutal, let's just change the wind chill. That's uncomfortable, right? Maybe brutal. I think Greg would probably say maybe uncomfortable. I don't think brutal for this.
It wouldn't be so bad if it weren't for the wind, right?
Right. We can say get -4. We can see that this winter, but it's going to be uncomfortable, certainly. Okay, so let's go to the surface map for the reflectivity precipitation type around this time. We saw that on the radar, an area of precipitation ahead of the front, or maybe even post-frontal, that's going to be right through us by the time we get to just a few hours from now this afternoon, with maybe a few snow showers, and after that, the cold air really comes rushing in, and winds are going to pick up. So you'll notice that a shift in the wind from west, or maybe slightly west-southwest or northwesterly, probably between 3 and 4 o'clock this afternoon. and then the cold air comes in. Let's switch to a different view, go to the GFS, please. And we'll just go to the GFS, and we'll go to just the national view with the US. And we can see that broad cyclone that John mentioned earlier that was just further to the west continues moving eastward. Here's the cold air beginning to plunge in. And look at the leading edge of that, with the band of rain and snow along the primary cold fronts is heading into parts of just northwestern Ohio near Toledo and those areas as it moves eastward. So if we step ahead, let's go to midnight tonight. 18 hours to our forecast. Thickness is falling significantly over us with a northerly wind. Just cold tonight, uncomfortably cold, brutally cold, use whatever adjective, depending on where you're from.
I don't know what Sergeant Rocco here is going to, it's going to be cold.
It's going to be cold. But a nice broad anticyclone, 10 Thursday night, coming into the U.S. Let's go ahead to tomorrow afternoon, 36 hours.
Some 500 thickness is a pretty
Tomorrow
long.
afternoon. That anticyclone comes in and then begins to recede. You can sort of see the skinny anticyclone here with warm induction already beginning to set up just to our southwest. Then another area of a little bit of light snow that break it out over parts of Minnesota.
Yeah.
So Sunday morning, 48 hours. So the cyclone that just goes to our south. 498 thickness is right on top. That's probably what's the coldest we've seen
I think it is.
this year, or certainly this month, as this cyclone heads to our south. But if there's going to be any snow, John, that snow is going to be to our south, so you're out of luck.
Of course it is. That's expected.
Monday, let's go to Monday. We'll quickly step through this to get to the more interesting event and then see that it's not going to happen. So a day later, we have another weak trough that goes by, brief period of warm advection, and then the cold advection just waiting in the wings toward west or parts of Minnesota. But again, nothing much in the way of significant precipitation with that. Advancing another day ahead, brought in a cyclone, starts to form. Here's our potential warm-up, looks promising. As the high moves, the thicknesses have recovered back to 530s. We'll go ahead one more day to 120 hours. Whoa, summer, or maybe spring. It's warm. I mean, nice, broad, warm advection. Ridge setting up over the southeast coast of the United States, and things begin to warm up. Thickness is now well above, or above 540 at this point. But the cold air, again, is not too far to the northwest. You can see where that cold advection is. Just, it's well north of Wausau, but it's in the northwestern part of our state.
Look at those 492 thicknesses up there in the mosquito lakes in Ontario.
Right, but just think, just a few days before, we were at 498, so it's really gone up. That air density is really lifted to the north. Another day ahead. Oh, so we got to step through this. Let's go back to 132. So we saw that varicosity to the north. It's now begun to move south where we have a front that's begun to set up. We can look at 850. There is certainly frontogenesis surface. You can see these broad southerly winds here and backbeat moisture from the Atlantic and the Gulf into the southeastern part of the United States and central part of the United States. I haven't looked carefully, but there may be some comments about the possibility of severe weather getting
The Storm Prediction Center issued day 6 and day 7 outlooks for convective activity. Day 6 being Arkansas area, and day 7 being Tennessee and the Mississippi and Alabama.
Okay, so that's going to be something that's going to be of interest. But this, with this varicosity here, we have moisture variable, and we have an active front with frontogenesis occurring along this band. This is going to be associated with banded precipitation. Right now, the models have us at liquid, starting off with liquid precipitation. And we go ahead.
I should point out that we've seen mostly Alberta clippers
Right.
for the last month, and this is one of the first Colorado lows we've seen.
Right. Right, and so this is, Eric said, again, the pattern has broadly changed, and I think actually, glad you mentioned that, I want to go back just for a moment. We'll come back to that. What triggers this is a low that actually, or a cutoff that actually comes down the west coast of the United States. I think it's on Monday, and they actually get showers and precipitation here, maybe even snow in the mountains. There, Los Angeles after that really warm period. That cutoff begins to inject back into the central part of the United States after. So the ridge is already beginning to break down. But focusing on this event, we'll go ahead 138 hours. Cyclone begins to move toward Arkansas. we cool off enough to turn over to snow, transition over to snow. This broad anticyclone to the north. That front really shows up well. It's going to be south of us at this point, just through Rockford perhaps. Another 6 hours ahead, 141, or 3 hours ahead, sorry. This point. Transition from snow to sleet, freezing rain, and just plain rain to the south, so just right on the edge. And let's keep going ahead in 3 hour increments. This is cycle 991.
No development. It's been
No development.
991 for a period of time.
Let's go ahead another quick.
Weakening.
992. Here's the precipitations. Again, we're just on the edge. We can even do a sounding right here. What a quick. Most likely precipitation type snow. Here's our sounding, forecast sounding. Again, all levels below zero, nicely saturated all the way up into the lower troposphere. Nice warm reduction signal, the wind's varying with height. This looks pretty promising.
Can I point something out?
Yeah.
Looks less promising, the fact that there was all that convection along the front to the south. Many times it seems that the models miscalculate how much moisture is taken out of the stream.
So that most of it could fall as convection in the warm sector.
Right.
North of it. So that's something we're gonna watch. I'm not convinced of this solution, and we'll see in a few moments why. Let's go ahead. Out of this.
Didn't you write a paper about that?
I think so.
The robber storms and everyone calling it the rover storm. Yeah.
Here we go ahead again. 992, this isn't really deepening. I think it goes down 1 millibar at some point in the next. There we go, 2 millibars. With some heavy precipitation. This isn't freezing rain or sleet. This is actually snow that's forecast by the model. And pretty strong winds as well. That's, it looks like a pretty impressive storm. That's Thursday afternoon. And then we go ahead again.
Right during our poster session.
Letting.
Now it's over. Like look down to 990, it hasn't changed in the last 3 hour period with the snow beginning to end and the cold air coming in. So how much does this actually produce? If we go to the, let's zoom in here, regional. Brace yourself if you this may be jaw dropping in terms of how much. So put your hand over your chin so your jaw on the floor. And look at the, first of all, just the 10-to-1 ratio for this.
That's a record.
Let's go for 24 hour accumulated.
numbers.
That's a record.
Again, 19.6. Now here's one of my first, this is a Morgan rule of thumb. I don't know if it really carries anywhere more than by just saying it once. But this, we're like on the axis of the heaviest snowfall. This is a week out, or a little less than a week out.
Mm-hmm. What's your point?
It can only go from perfect to worse, right? The cyclone goes to the south, it goes to the north around.
Definitely right.
If this were 12 hours before the event, I would get excited. At this point, it's snow. It's, maybe snow, maybe rain, maybe sleet, who knows?
If it's 12 hours before the event, you can't prepare you for the dry slot and see a water vapor that comes out of nowhere.
That's right. That's also true.
Not in this scenario.
This is definitely. Let's also look, I mean, I know some people were fans of Kucher, and this is just more for the. Okay. All right.
All right.
That's another way of calculating the accumulated snow.
That will not happen. That will not happen.
So it's gonna be a dry snow.
Sort of like the dry heat in Tucson.
Right. So, okay. But let's get rid of Kucher. Let's just do 10-to-1. That's probably the best we can do at this time if we're trying to look at something. And look at some other models. Right? We don't look at just one model here, we look at a whole bunch of them. So, no, I mean, we can stay here. Let's click back on this, please. Click here, and we'll look at the compare models' latest runs. So what do we have? We only have 3 available to look at. Go to the ECWF resolution.
I would still accept that.
That's still a
That's
decent.
the best of the year. It happens.
Right, that would be a decent snowfall for some people. The Canadian model, oh yeah, sign me up.
No, I think the storm passed.
But does anyone actually respect that?
Right. And then the GFS, we've already seen that as well. So there's a range of solutions with this. We could look at the synoptic evolution in the forecast. And in fact, let's just do that. Let's click out of this.
Need those impacts.
Before you do
Yeah.
that, try going instead of 56 to 54, 52 to just see if it's timing.
Good point. Excellent point.
For what?
So look at the different times here. Let's go 1/5. Let's go back 6 hours. This is GFS. This is still GFS. And then let's go ahead. Yeah, let's go ahead a little bit. And so what are the numbers? So before still GDPS.
It's like 30
Go ahead.
fast. So go back.
44,
144.
and look at the,
Okay.
4, 7. It looks like it's just faster.
Yeah, that's the best. Or the way the UK method comes out, it's way up on 2.5. So, again, this is an unusual situation. Actually, let's stick with the GFS. Let's go back here. Go to model trend. Actually, we're always interested at 156. 156, yeah, and then just, sorry, let's go to the end of this. What time is that? That's 160. Oh, 162. These are all at the same time, right? So you can compare how the models have trended over the last several days with the system. Kind of over us, maybe a little bit to the north, right over us. This is snow that just rain. That was just yesterday morning, right? So lots of solutions here. Don't get super excited about it. John, just hold your.
Oh, I am, I'm excited, but not overly so.
Okay.
A lot could go wrong.
And the very last thing I wanted to show you was just this change in the pattern. And let's go back to the full map of the US. So it's a change of zoom to US or national.
This is when the weekend's really fun as an intervention. You know, you go Saturday, Sunday, and not look at it again till Monday. Then you have a little more confidence.
Variable heights of vorticity. So what I wanted to point out on this, and I guess there are lots of different ways of doing this, let's go back to the 0 hour on this. And I'm sorry, Pete, on this, but I think one other change, so we can get a bigger view of this continental. Okay, so here's this sprawling ridge that we've seen both in the last 3 weeks or so off the west coast of the United States. And just watch how this begins to break down a bit, and how the pattern at least subtly begins to change. And we can just go ahead every day. We don't have to go through. And so there's that big ridge still in place. And we just keep looking ahead. Here comes a nice
Things out of the Bering Sea, isn't it, that stream?
disturbance that might quick through it. We can just keep going. Progressively, just kind of. This is a really intense, right, the ridge is still there, I mean, don't get me wrong on that, but that's what we've broken through. Finally, there's precipitation along the west coast that'll be useful for them, helpful to some extent for them. And with that change, at least over the parts of the United States, we've gone from having a trough over us to a nice broad southwesterly flow that's set up. But the ridge is still there. Let's keep going. There's our cyclone that begins to spin up. Ridge is there, but it looks like we're now getting some other intruders to the northwest. And the ridge, I think, flattens just a little bit at least. We get back to cold. And we can keep stepping.
A little more progressive.
Right, pattern just begins to open up a bit more.
Westerly flow means warm again.
Right, so the westerly flow down sloping, that's going to spread over everywhere east of the Rockies, beginning to warm up.
Ooh, southwestern flow.
There's a ridge again.
So, ridge still kind of lurking in the background, but this might be the beginning of a change in the pattern. Another opportunity for some severe weather, perhaps. We have a deep trough over the southwest.
It's enormously far south, too, it's like to me.
Right. That's just bizarre.
Yeah, sure.
Look at that analysis. So, watching for perhaps the beginning of some sort of pattern change, it's not fairly evident to get rid of the ridge, but at least there's some things that can break through it, which gives much needed precipitation to the southwestern and western parts of the United States. Maybe opening up the opportunity for some severe weather over the central part of the United States. And with that, maybe some snow events for us, or at least more precipitation for us where we need it. Anyway,
Look at
that's,
California here. They ought to get something out of this.
right, yeah, let's look at the surface map for that. Surface precip. Yeah, that one, yeah, there we go. Actually, no,
Nothing.
that's pretty dry. So, that's it. Some snow showers this afternoon in the next 2 to 3 hours. We get cold. Again, you can have all flavors, just cold, uncomfortably cold, brutally cold, you choose your adjective based on where you're from. And then the possibility of a mid to end of week weather event that could produce a lot of snow, or it could just be rain to snow and ice, or just some rain showers that would cool off. So, I'll leave it at that. Thanks, Pete, and thanks, John.